Okay, so this lecture is going to be covering Chapter 3, which is on research and general research methods. And while most of you have not said that your main interest is to become a researcher, it is important for people in general and also especially for clinicians or people who want to do something in the social sciences to have the ability to read and interpret research. So that is the purpose of this lecture. Okay, so in general, some people are pretty skeptical about scientific research, and we've talked a little bit about this before. So some of the reasons why people may be skeptical about scientific research are that oftentimes even the experts disagree on research interpretations or findings, and so this can be particularly problematic in terms of making people have a lot of trust or confidence in our findings. So this is one problem in terms of skepticism about scientific research. Another issue, and I think we've also talked about this before, is that research that is presented in media is often overly simplified. So, and this is one reason why it can appear as if experts are sort of disagreeing on interpretations or outcomes of research. Because if the media is presenting findings from one study in a particularly oversimplified way, then the next week we can see findings presented that seem to contradict the findings from the first study, even though they actually may not. A third reason why people may be skeptical about scientific research is that actual research findings are often in conflict with one another. So this is just a true statement about the world. We often find findings from research studies that are directly contradictory to one another, and we're not often sure why that is. And then even when we do find consistent answers, a lot of times research doesn't give us a clear-cut way to go forward. So oftentimes, even if we do know, for example, that, just to use an example we've been talking about, that let's say we know parenting impacts child anxiety symptoms, it's not clear exactly what we can do about that, or if that is something we can do something about. So even when we do find an answer to something, we may not have a way forward. And then the fifth point, and that's one that we've talked a little bit about in class as well, is that even when there is consensus amongst experts and research findings, people often prefer to draw from their personal experience instead of drawing from research findings. So even when, for example, we know pretty well that cigarette smoking relates to risk for all sorts of bad outcomes, people often prefer to draw from personal experience regarding this topic. So maybe they knew, their grandfather smoked his whole life and he didn't get sick. So they may prefer to draw from that personal experience instead of drawing from research findings. Okay. So on the flip side, when should we believe research, or when should we pay attention to research? So when sample sizes are large, this is generally better. So that's something that I think most people can wrap their minds around, that if I'm trying to study a topic and I'm studying it in 10 people, it's possible that those 10 people don't actually represent the larger population. No single study is perfect, so research from multiple groups is something to look for. So when different research groups are finding similar findings across the board and across different studies, that's when we can start to have confidence in research findings. In general, what we're looking for is the accumulation of findings. So we've talked a little bit about reviews or meta-analyses. So when we can find these types of papers that are the accumulation of many different studies, and if they are finding some consistent things amongst all of the studies included, that can be something that we have more confidence in. Something else to pay attention to are multiple methods converging on a similar finding. So for example, if I want to measure parenting via parent self-report, and I want to measure parenting via kids' report on their parents' parenting style, And then I want to do a laboratory task where I have parents and children do things together, and I record these interactions, and then I have people code them for parenting style. And let's say I do all these different methods and they all converge on this same finding, which is that parenting relates to child outcomes in terms of symptoms. You can start to have more confidence in this finding because of the multiple methods. Okay, and then the last point I want to make is just to always evaluate research critically, which is something that we have been talking about. So this is a quote from Stephen Hawking, that the greatest enemy of knowledge is not ignorance, it is the illusion of knowledge. And so this is just to make the point that oftentimes the biggest problems that have come up in the history of science is feeling like we know something and not that we don't know something. So having this sort of illusion that we have knowledge can be much more problematic than being able to admit that we don't. And so I would really encourage all of us and in this class to be able to say we don't know the answer to something, because when you can say that, when you're able to say that, that's when you can start actually trying to ask questions to answer that gap in knowledge, instead of trying to pretend like we know things that we don't know. Okay, so this is an example of when science is ignored. So I'm not going to play the video right here in this PowerPoint presentation, but you can all, if you're curious, play this video if you want to get some background information on this Wakefield study. So basically, Andrew Wakefield misrepresented some medical histories of 12 patients that he included in this study. And this study was put out in 1998. And basically, his findings supported this claim that vaccines caused autism. And there are a lot of flaws in this article, amongst them that there were only 12 patients and all sorts of other statistical flaws. And several studies attempted to replicate this and were unable to do so. It basically came out later that Wakefield had purposely altered medical histories of subjects in order to get these outcomes. So this study was actually retracted in 2004. So the scientific community was able to sort of see these flaws and retract this study. So even though this study was retracted and people in the scientific community have done a lot of work to debunk this association between vaccinations and autism, it's probably no surprise to all of you that this is still a popular idea amongst some celebrities and in the media, and even amongst some experts who publish books. So there's still this pretty prevalent thought or theory about this idea that when kids get vaccinated, they sometimes have an increase in autism symptoms, or actually just a whole new onset of autism. And one of the reasons that this particular work from Wakefield has really caught on is that the age range in which kids get vaccinated is often the age range when parents will begin to see autism symptoms. So this is sort of a ripe ground for a lot of sort of people seeing, anecdotally seeing these associations. Even though now we have a lot of work that suggests that these associations are not in fact real, a lot of people's sort of thoughts about this are sort of came from Wakefield's study, and this just sort of kept on going on even though the study has been retracted. Unfortunately, we have seen an increase in some pretty severe diseases that are associated with vaccinations. So we've seen the cases of measles have dramatically increased recently, and this is thought to be due to people not vaccinating their kids. So this is an example of where science can kind of have a pretty negative impact on public health outcomes. I didn't mean to advance the slide there. The way that we have known that is that when we put headphones on this woman here, for example, and she's hearing something different than what is actually in the environment, often this part breaks down here, that the child is unfortunately no longer able to actually communicate. So it seems that it's really sort of what's going on for her that is driving a lot of this communication. So that's another example of where science can sort of put out some ideas, and then if those ideas are particularly alluring in some way, or that particularly easy for people to have these experiences where it seems real, even once scientists do some more careful studies to see if what they had originally put out is valid, a lot of times those follow-up studies aren't disseminated to the public as broadly as they should be. Okay, so we're going to talk a little bit more about the scientific method. We've talked about this, I think, previously before when talking about reading articles. The scientific method, you probably have all heard this spiel before, but I'll go through it really quickly. Basically includes stating a clear theory. And a theory is basically an idea or about how something works. And from this theory, you can form hypotheses. And hypotheses are direct, concrete predictions that one would derive from the theory. So let's stick with this example of parenting and anxiety. If I have this theory that, let's say, parenting impacts children's symptoms, a hypothesis I might have would be, when I ask kids to self-report on their parents' parenting style, kids who report higher controlling parenting style will also be kids who, on a self-report measure, report higher anxiety symptoms. So the important thing about the hypothesis is that it's something concrete and can be measured. And another aspect that's important about the hypothesis is that it's falsifiable. So it has to be something that it would be possible to find or observe data that would make that hypothesis untrue. So for example, if I told you my hypothesis is that there's a dragon in my room right now, and you said, okay, well, let's try to observe that dragon, and you said, well, I don't see any footsteps or footprints from the dragon, and I said, oh, well, the dragon's flying all the time, so there's no footprints, and you said, well, I can't see the dragon, so there's no observable data in terms of visual information. And I might say, oh, well, the dragon is invisible sometimes, that's why you don't see it. So on and so forth. So if the hypothesis is something that can't be unsupported by data, then it's not very useful. So we need to be able to make observations or take measurements to either support or falsify the hypothesis. And by doing that, we are able to evaluate the theory. So the more you can support hypotheses that are derived from a theory, then the more we are going to begin to believe that theory to be true. And once we believe that theory to be true, then we want to share these results more broadly with the scientific community and also broader community. So more details on what a theory is. It's an organized set of principles. It describes, predicts, and explains some sort of phenomena. So for another example of a theory would be evolutionary theory. So Darwin's theory was that basically traits can be passed from parents to offspring, and that mechanism explains the development of different types of species across time. So hypothesis that one would derive from that theory, which would be a specific testable prediction, would be that parents should have traits that are in common with their offspring. So that's just one example. There are many different hypotheses you could derive there. But the important thing here about a hypothesis is that it's derived from the theory. It's something that we can observe data regarding it, and it must be falsifiable. Okay, so switching gears. So epidemiological research is basically research that covers the topic of the nature and distribution of disorders, and in our case, we're interested in childhood disorders. So it's basically how many people have these disorders and when do they have these disorders. So incidence is basically the amount of new cases of a disorder over a specific period of time. So, for example, I may be interested in the incidence rate of anxiety disorders in kids between the ages of 5 and 6. So if I said incidence rate, I would mean how many kids have a new case of an anxiety disorder that they didn't previously had during this 1 year period. Prevalence is different than incidence rates in that it refers to all cases. So for example, if I was interested in 5-year-olds again, but I was interested in their prevalence rates of anxiety disorders, I'd be interested in how many have ever had an anxiety disorder before. So it's lifetime history of an anxiety disorder, including current disorders. So prevalence rates are going to be higher than incidence rates. Incidence rates are referring to new onset disorders. And in terms of being able to measure how many kids have disorders at different times, there are two different main approaches to doing this. One is retrospective, meaning you could even ask adults, say we ask adults with anxiety disorders, when did you first experience anxiety? That would be retrospective because they would be recalling when they had first had the disorder. And then there are prospective studies. So that would be collecting longitudinal data from a large sample of kids across time. So maybe I measure the amount of kids with anxiety disorders in a large cohort of kids when they're all 3 years old, and then I bring them back into the lab again when they're all 9 years old, and I again assess, well, how many new onset disorders were there between the ages of 3 and 9, and then maybe I follow up and I bring those kids back when they're all 16. So you get the idea here. That would be sort of measuring onsets of disorders across time in a prospective way, not just asking people to retrospectively recall when they first began to experience psychopathology. And in general, we're going to trust data more when it comes from prospective studies, and that is because retrospective data is considered to be not as accurate because of the fact that people don't always have an accurate recall of their experiences across time. Okay, so you guys have probably all gotten this spiel as well, but basically I wanted to go through this relatively quickly. So correlation, here on the left is a depiction of a positive correlation. So positive correlation is when you have more exposure to something, or more of something, you have more of something else. So in this case, more exposure to violent TV is correlated to more acts of aggression in children. So these two things are positively correlated because as one goes up, the other goes up. This right here is a negative correlation, meaning as one thing goes up, another thing goes down. So in this case, this looks like as people are more optimistic, their tendency to be ill is less. So as optimism goes up, illness is going down. So negative correlation doesn't mean that these things are unrelated. It means that they are related in the opposite direction. So as one is going up, the other is going down, which is different than positive correlation, because in a positive correlation, as one goes up, the other goes up. And then down here we have this, this is a zero correlation. And so this is just when two variables are unrelated. So the example here is phases of the moon. So according to this data, which is probably representative of reality, as the phase of the moon changes, we don't get more or less crime. These are just completely unrelated things. And the way that you can evaluate a correlation is by seeing how steep the line is. So the steeper the line, this is a extremely steep line, that means the magnitude of the correlation is higher. Same for this. This is a very steep line versus this line, which is basically flat, meaning there is no relationship. And the other thing to pay attention to in a scatter plot like this is how close these dots are to this line. So if all these dots are pretty much hovering right around the line, then you have a pretty strong correlation, versus here you see all these dots are kind of just all over the place. They're not sort of hovering next to the line. So this is a very weak correlation. This is actually a zero correlation. Okay, so I also want to make the point that correlation is not the same as causation. So just because two variables are related doesn't mean that they cause one another. So for that previous example, we had found that the amount of TV violence kids watch relates to the amount of aggressive acts they commit. And so you might conclude from that is that watching TV violence causes aggression. That would be one interpretation, although the correlation doesn't support that necessarily. The other could be that being a more aggressive kid leads you to watch more TV violence. So basically, in this case, aggression would cause the watching of TV violence. Or this third option, which is very important, is that there's some third variable here that explains this apparent association. So, for example, it could be that kids with physically abusive parents tend to be more aggressive because of a genetic loading, and also tend to watch more violence on TV, because their parents allow them to watch more violence on TV. So in this case, this third variable here would be parental hostility or aggression or abuse. Forgot what I said, but whatever it is, it would be here, and it would be explaining this association. And it wouldn't be at all true that aggression causes kids to watch TV violence, or that watching TV violence causes kids to be aggressive. Okay, so this is a quote saying that with very few exceptions, there is no such thing as a single basic necessary and sufficient cause. So for most of the phenomena that we're going to talk about in here, there is not one neat cause. There are going to be multiple causes, including things from the biological realm, like genetics or neural underpinnings of behavior, things from the social realm, and things from the psychological realm as well. And all of these things are going to overlap and interact with one another to lead to outcomes. So usually we're not talking about one particular cause for one particular outcome. Okay, so a moderator. A moderator is a variable that influences the direction or strength of a relationship between a variable. So in this case, if we see that physical abuse in childhood leads to internalizing psychological problems in kids, a moderator of that variable could be sex of the child. So in this case, it would be that females are more impacted by severity of physical abuse in terms of relating to internalizing problems versus males. So in this case, males are, even though they may experience high levels of physical abuse, they're not as likely to experience internalizing problems. So gender or sex of the child is moderating this association. Basically, this association is different depending on this variable. So let's see, another example of this would be if we're thinking about the relationship between free time and video game playing. So basically, let's say in this example, people with more free time spend more time playing video games. This association is probably moderated by age, such that for young people, free time is very directly related to playing video games, but for older people, free time is not very associated with playing video games. So it could be that old people with free time may do things like read books or read the newspaper or take a walk, and they may not necessarily play a video game. So while there is this association, it would be moderated by age. Moderation is basically saying the same thing as having an interaction. So it's saying that these two variables interact with one another to cause this outcome or to relate to this outcome. So that's different than a mediator. So mediator is a variable that basically comes between two other variables. So the definition is the process, mechanism, or means through which a variable produces a specific outcome. So in this example, let's say we know there's this relationship between mother's negative mood and children having problematic behavior. A mediator of this could be mother's use of discipline. So moms who have more negative moods may use more harsh discipline, and harsh discipline may relate to kids having problematic behavior. So basically, this variable explains this relationship between mother's negative mood and child's problem behavior. So it's basically a pretty mechanistic explanation. So it's mediating, it's coming between two variables. Okay, so switching gears again. So in terms of evaluating interventions, this is important because the main goal for us is to come up with ways of treating or even preventing childhood psychological problems. So we need to have good ways of evaluating whether our interventions are working. Unfortunately, many standardly used treatments today have not been formally evaluated, although some of them have. So one of the main things to look for in terms of evaluating interventions is the use of a randomized controlled trial, or an RCT. This means that kids are randomly assigned to a treatment or a control condition. And this is important so that we have some baseline to compare to. Okay. PowerPoint seems to have frozen. Okay, so things that we need to keep in mind when thinking about measurement in terms of studying child behavior. we're going to go through each of these things, but our standardization, types of measurement we use, types of reporting, and then psychophysiology and neuroimaging. Oh, and then observation. So in terms of standardization, the main thing to keep in mind here is that we need to use existing norms to interpret a measurement procedure. So here is just an example of a pretty well-known standardized measurement. So this is an intelligence score, and you can see that these scores are normally distributed, meaning there's this bell curve here, and about 96% of people who take an IQ test are going to fall within this range right here. And then even less of them, 68%, will fall in this range right here. And so 100 is average, and you can go plus or minus that on either side of the IQ range. And as you go out into these tails, you're going to get less and less people who have these IQs. So only 0.1% of the population has an IQ below 55, and then only 0.1 of the population has an IQ above 145. So most people are sort of falling right here in this average range. And so this is just displaying how a normed measurement can be helpful in telling you what's average. So reliability is another important thing to keep in mind about our measurement. So test-retest reliability is basically whether the results of a test are similar or the same when that test is taken multiple times. So if I were measuring your IQ, for example, if I give you the IQ test 4 times, your scores should be pretty similar because the IQ test should be pretty reliable in terms of its test-retest reliability. If you were to take the IQ test and get wildly different scores depending on when you had taken it, we would say that that IQ test was not very reliable, meaning it had low test-retest reliability, and that would be extremely problematic. That would be sort of like if we had a scale that you were trying to measure your weight with, and every time you got on that scale it told you something wildly different. That scale would not be very useful. Internal consistency is whether all parts of that test contribute in a meaningful way and relate to one another. So for example, if we're thinking of the IQ test, the way that you perform on one part of that test should definitely relate to the way you would perform on another part of that test. It doesn't mean it has to be a one-to-one relationship, but they should definitely be related to one another. So that's internal consistency. Another example of something being internally consistent would be if we were trying to measure depression symptoms, for example. And so an internally consistent measure would be something like, how often in the last 2 weeks have you felt down? And then the next question could be something like, how frequently do you feel down? And then the next one could be something like, how often are you sad? So all of those questions are very similar, and you would think you would get similar answers to those questions. So we would think that would be a very internally consistent measure. If I try to make a depression measure where I ask questions like, how sad are you today? And then my next question was, how tall are you today? And then the next question was, do you like the color blue? You would think that the answers to those questions don't necessarily relate to one another, and so that measure would be internally inconsistent. Okay, another form of reliability is inter-rater reliability. That's basically whether various raters agree on the test outcome. So if we're thinking of the example where we are videotaping parents and kids have interactions, we would have different raters observe those videotapes and rate the parents for parenting style. And if we had inter-rater reliability, those raters would more or less agree on what ratings they were giving to different videos. But if we had raters rating these videos very differently from one another, we would have a problem with reliability or measurement, so we wouldn't have high inter-rater reliability. Okay, so next we're going to talk a little bit about validity. So validity is the extent to which a test actually measures what it's supposed to measure. So face validity is basically whether the test appears to measure the construct you're interested in. So the example I gave before about a depression measure where I ask, do you like the color blue? And what is your height today? those questions would not have a lot of face validity in terms of the construct of depression. So face validity is basically just, does it seem like the test is measuring the thing we're interested in measuring? Construct validity is whether a score on a measure would behave as we might predict by theory or by past research. For example, for the IQ example, we would expect that IQ scores should predict grades that kids receive in school. So we would have good construct validity if IQ predicted or correlated to GPA. We can have convergent validity, meaning that two things that go together do relate to one another. So we would, again, an example of something that would represent convergent validity would be IQ and GPA. And then we have discriminant validity, meaning that things that we would expect to be unrelated should be unrelated. So for example, we would expect that IQ and depression would be unrelated. So if those two things in our study were highly related, IQ and depression scores, we would wonder about why that is, and it would suggest we didn't have good discriminant validity in our measures. So commonly used measures when studying psychopathology in kids are interviews, questionnaires, observations. So in terms of interviews, we can use unstructured clinical interviews, which is what it sounds like. Basically, there's not a lot of specific questions we're asking, but rather the clinician is doing an interview to get at whatever symptoms or disorders we're interested in. We can do structured interviews, which is basically what it sounds like again, where there are structured questions that the interviewers are asking people, or we can do questionnaires, meaning that we have people sort of report on their own symptoms. So some common problems when thinking about measuring psychopathology in kids is that we often have people who have inaccurate memory recall. So we have people who are not able to recall that either they had a previous, let's say for example, depression episode, or they're not able to recall that their child did. So this can be a problem in terms of just sort of asking people about psychopathology. Another problem, especially in kids, is verbal ability. So kids below the age of 7 don't have fully developed verbal ability. So if you're trying to ask them questions, let's say with a questionnaire, if it's written, they may have trouble reading it, and then even if it's not written, even if you have someone read them the questions, they may have difficulty understanding exactly what the questions mean, and so you might not be sure if their answers are legitimate answers, because they may not have understood what the questions themselves were actually asking. And so there are some ways around this that people do use, but this is generally a problem. And we do find that in general, questionnaires and interviews are less reliable at younger ages. So for kid research, this is particularly problematic. Okay, so in terms of the difference between different types of reporting, we have self-report measures, which means a child or a parent reports on their own behavior, their own thoughts, or their own feelings. Informant report measures are basically a person who's acquainted with the child providing information on the child. So a parent could report on the child's symptoms, or a teacher could report on what kinds of behaviors they see in the classroom, or a friend could report on what kinds of things they see going on with that child. So those would be informants versus self-report measures. There are multiple types of observations we can use to collect data. So we can do naturalistic observations. For example, we can go to classrooms and observe child behavior, or we can even go into homes and observe behavior. The pros for naturalistic observations are that they're likely very representative of natural behaviors these kids are displaying because they're in their home environment. The cons are that we don't have control over the situation, so all sorts of things can happen in a classroom or a home that aren't part of our research design, and that may differ by child, and so we don't have a lot of control over what kinds of situations are happening. So we can also do structured observations in the lab, and this is a very common thing to do. So we can have specific tasks that parents and kids do together. So for example, we can say, we want you to put this puzzle together, and we can videotape them putting the puzzle together. And in that way, we have a lot of control over what exactly is going on in the interaction. So the pro is that we have greater control. We can focus their attention on one particular task. The con here is that it may not be very representative of their natural behavior. So parents and kids may behave differently in the lab than they would at home. They know that they're being watched, and they're doing something they may not normally do. So for example, they may not normally sit alone in a room doing a puzzle together. So we may be kind of observing them do something that's not typical for them, and in that way they wouldn't be displaying typical behavior. Okay, so those are all about self-report and observations of behaviors and clinical interviewing, ways of gathering information to study psychopathology in kids. We can also try to study biological or neurological underpinnings of psychological problems in kids. So we can study physiological responses like heart rate, blood pressure, breathing, or pupil dilation. We can study electrical brain activity using EEG methods, which I'll talk a little bit about. This is EEG measures electrical brain activity. Or we can use neuroimaging techniques like MRI or fMRI. And so these neuroimaging techniques basically measure blood flow in the brain or actual structures in the brain. Okay, so EEG is what my research is based off of, so I'm going to give you a little more in-depth example of what I study. So basically, EEG is measuring electrical activity that results from neurons firing. So this kid right here, you can see he has an EEG cap on. These little light up things are the electrodes. You can measure EEG while someone is just sitting there at rest. You can measure it while they're sleeping. Or you can measure it in relationship to activities. So in this example, the child is looks to be doing something, playing a game on this iPad, and presumably these researchers are measuring brain activity in relation to whatever thing the child is doing on this iPad. So in my study, we study event-related potentials, or ERPs, which are basically when you're measuring ongoing EEG, but you're measuring that while children complete a task on a computer. And we're looking at EEG activity that's locked to a specific event. So for example, we can look at brain activity that happens when kids are watching scary pictures, viewing scary pictures, or we can look at brain activity that happens when children make mistakes, which is a lot of what my work focuses on. And so we are able to measure these ERPs on the scalp with those electrodes. And this is electrical activity that occurs when millions of neurons are firing together in a synchronized way. So we're not measuring with an EEG cap, we're not measuring one particular neuron firing here or there. We're measuring thousands or millions of neurons that are lined up together in one way that are firing all together. And in that way, we're able to see this electrical signal that rises to the scalp. So in my work, I talked a little bit about this before, but I wanted to give you more information. We measure the neural response to making mistakes. So in this case, this person is completing this task on the computer where they have to pay attention. They have to press either the right or left button depending on what letter is in the center here. And we have them doing this over and over and over again until eventually they make mistakes. And we can do this with a flankers task. So in this case, we have them respond to the direction of the center arrow. In this case, we're having them respond to which way that triangle is pointed. But basically what we're doing is recording EEG while people do these tasks, and we get this average response on the top of the head that is the average response when they make correct answers. And then we also get this average response when people make mistakes. And this is called the error-related negativity, or ERN. And you can see that here it's a negative deflection at frontocentral electrodes occurring about 50 milliseconds, or right around the time that people make mistakes. So on the head map here, blue is negativity, and you can see that this is sort of localizing at the top of the head. On this plot, negative is plotted up. Here is the place where the person was making the response. So 0 is when they click the button. And you can see here, the dark line represents the response to errors, and the dotted line is the response to correct responses. There's this sharp negative deflection right around the time someone makes a mistake. And so we think of this as basically your brain is keeping track of whether you're making a correct response or an error. Okay, so you might wonder, well, why does that matter? And so the reason it matters is that The ERN has been shown to be increased in anxious people, and that's been found in over 45 studies now. And we've recently moved that work to looking at this in kids. So in this study, we looked at a group of 6-year-olds and we measured their ERN. And we brought them back when they were all 9, and we looked at which kids went on to develop an anxiety disorder, and we saw that we had 26 kids with a new onset anxiety disorder. The kids that went on to have an anxiety disorder had an increased ERN at age 6 compared to the kids who were going to go on to not have an anxiety disorder. And these results are significant if we control for baseline anxiety symptoms. So the idea here is that the ERN may be a early emerging biomarker or neural marker of risk for anxiety. And we talked last time a bit about how NIMH is very interested in identifying neural markers of risk for disorders as a way of being able to target psychopathology early in life. Okay, so that was looking at EEG. There are other ways that people measure psychopathology or try to measure psychopathology in the brain. So you can use structural methods, neuroimaging methods. So those are basically measuring brain tissue. So you can use MRI or CT scans, and you're going to get white matter and gray matter images of those things. So you can see that here. This is an example of a structural image. You can also do functional measurement. So functional is basically looking at how the brain functions. So functional MRI or fMRI is looking at how blood flows to different parts of the brain. So MRI is looking at just the structure of the tissue. fMRI is looking at how blood flows to particular parts of the brain when people are doing particular things. It is important to note that fMRI is measuring a time course that is a lot slower than EEG. So blood flows to the brain when parts of the brain are being used, but this is something that happens in a much slower time scale than the electrical activity that is happening when neurons are firing together. So EEG is very good at measuring time course of neural activity, and fMRI is very good at telling you where in the brain activity is occurring, even though it's not telling you precisely when it is occurring. Diffusion MRI is another type of measure where we're basically looking at connections between brain regions. You don't need to know many more details other than that. So the thing to know here is that MRI is looking at structural aspects of the brain. fMRI is looking at functional aspects of the brain, like where blood flows. And then diffusion MRI is looking at connections between different brain regions. Okay, so some other things to keep in mind when evaluating research is the validity of the study. So internal validity of the study is the extent to which the particular variable, rather than outside variables, accounted for the results. And external validity is the extent to which we can generalize our findings from that study to the general public, to other settings, other times, and other types of measurement. So internal validity would be problematic if, for example, I only recruited, highly depressed individuals, and then I try to measure how mood relates to weather, for example. That I may have a problem with internal reliability here because I've only recruited participants in a certain range of depression, and that may alter my findings. And then external validity is just the extent to which you can use the findings from the current study to give you answers about a more wider or more general audience or population, I should say. Okay, so this leads us to this issue of thinking about the sample, which is always something we should do when we're evaluating research. People report what's called descriptives in most publications, where they are telling you how many people were in the study, what were their ages, what's their socioeconomic status, what is their race and ethnicity. Sometimes they report on their IQ, their developmental level. And so this is important in terms of being able to generalize from the results of the study to other populations. It's also very important to consider psychological comorbidities. So if we're studying, for example, depression, and we just recruit a sample based on depression levels, we have also recruited a sample that's going to tend to have a lot of anxiety. So we need to make sure that we're considering this fact that depression is often comorbid with anxiety, and that whenever we're studying depression, we're probably also studying anxiety, unless we take particular care to control for that comorbidity. When you're evaluating the sample of a study, it's also important to think about whether the sample was randomly selected or whether this was a sample of convenience. So for example, I recruited my sample all from children of Florida State University professors because I happen to know a lot of professors. That would be a sample of convenience, and it may not actually represent the population at large. So for example, it may not represent children in Tallahassee because I just recruited from this small sample of the population. Okay, so an independent variable is the variable that is expected to cause a change in the dependent variable. So in other words, the independent variable is the variable that is manipulated by the researcher or experimenter in the design. The dependent variable is the variable that is expected to be influenced by the independent variable. So for example, in a study where I wanted to see whether parenting style impacted child anxiety symptoms, the independent variable would be parenting style, the dependent variable would be child anxiety symptoms. So if I designed an intervention to change parenting style, I would be manipulating the independent variable, or the IV, which is parenting style, and the hope would be, or the hypothesis would be, that the dependent variable, or the DV, child anxiety symptoms, would be impacted by changing the IV. So we're not going to do a quiz for this one, but basically this is an example where a researcher wants to study the amount of time a student spends studying for their abnormal child exam, that should say abnormal child psychology exam, and they want to see whether the amount of time studying affects their test score on the first exam. So in this case, what would the IV be? So the IV would be basically the amount of time the student spends studying, and the DV would be their test score on their first exam. And so the hypothesis is that the independent variable of time spent studying will impact the dependent variable, which is the score on their exam. Okay, so there are different types of design for research. So one is experimental, which is where you create an experiment and you randomly assign people to different groups, and you're able to control a lot of external sources of noise in your data. And then there are some non-experimental designs where we're looking at correlations between things. We're examining relationships that naturally vary in the population, and we can't determine causality because we are not changing the independent variable like we do in an experimental design. So an example of an experimental design would be if I design an intervention to change parenting style, and I randomly assign people to my intervention group and then to a control group, and I saw how changes in parenting impacted outcomes for kids, or anxiety symptoms in kids. So that would be an example of an experimental design. A non-experimental design to study that same topic would be to get a large sample of parents and kids, measure parenting style and measuring kids' anxiety, and looking to see whether those two things are correlated. Now, we wouldn't be able to assume causality from that, but we would at least be able to see if these things are related in the general public. So prospective design, I already talked a little bit about that, is following a sample longitudinally. This is a difficult type of research to do because it is extremely time consuming, and you have this risk of attrition or dropout. Retrospective research, like we talked about, is where you gather information from people about what they recall in their previous experience. And so the problem with this is that there's a lot of recall bias and distortion. The benefit to this is that you only have to collect data at one time point, and you don't have this risk of dropout or attrition. Other research designs include case studies, which is where you follow one individual or one particular case over time. This can provide a very rich narrative or descriptives about a particular phenomenon. It's often not considered scientific in that there's no random assignment and there's no general population, it's just one particular case. There are between group comparison designs where you, like we mentioned before, you have an experimental group and a control group, and you randomly assign people to those groups. So that would be like the example of doing a parenting intervention in one group and a control group for the other. Or cross-sectional design, where you just take people at different ages studied at the same time point, for example. So if I just took a bunch of people at the same time who are all different ages, and let's say I also measured anxiety, and maybe I get a relationship between age and anxiety, I would conclude that there is a cross-sectional relationship between age and anxiety symptoms. To study this same phenomena longitudinally, I would get measurements from the same individuals studied at different time points. So, for example, if I brought those people into the lab when they were 10 and then again when they were 15 years old, and I saw that within the same individuals, longitudinally, anxiety symptoms increased over time, that would be a superior design to the cross-sectional design I just described. So there are differences in terms of qualitative versus quantitative research. So qualitative research includes narrative accounts or descriptives, people's interpretation of context and meaning. Focus groups are an example of qualitative research. And then there is quantitative research, where we try to isolate variables of interest while controlling for other variables. We do statistical analyses. These are measurable, observable phenomena that we are trying to quantify or make into numbers so that we can do statistical analyses on those things. Okay, so in terms of ethics in research, it is important to make sure we balance the potential benefits for participants against the potential risks. And in all studies, we would like to have the potential benefits of the knowledge we're gaining to be more than the potential risks we are posing to participants. It's important to get informed consent from both children, adolescents, and their parents. So informed consent means that we are telling them what the study is about, why we're doing it, what it involves, what they're likely to get out of it, what are their potential risks. And we have them sign a form if they're over 18, and then for children and adolescents below the age of 18, we get what's called assent, which is their verbal agreement to participate in the study. It's important to use non-harmful procedures. Some of the experiments we have talked about or are going to talk about use procedures that could cause harm to individuals, and when we're doing psychological research, it is important to make sure you consider potential harm from your research studies. And so every institution or university has what's called an IRB, or Institutional Review Board. And so researchers have to write up what their study is going to be about and submit it to the IRB before they can actually even begin collecting data. And the IRB is composed of a group of people who are scientists and people from the community, and they read over what you're proposing to do in your study, and then they give you feedback on whether they think that's okay in terms of ethics or not. And if they have problems, you have to address those, and in order to collect data, you must have IRB approval. Participation in our research is always voluntary, and we want to make sure we're keeping in mind subtle ways we might pressure people, and we want to make sure that the study is actually voluntary. So for example, if I offered people $100,000 to participate in 1 hour of EEG research, it wouldn't really be viewed as voluntary anymore because of the substantial reward I was giving to people, and maybe a lot of pressure. So we do offer participant payment, but you want it to be in the normal range. So for example, $10 or $20 per hour, or some research credit. But we want to make sure that our participation is voluntary. This can create a bias in terms of the topics we're studying, because the people we're studying are the kinds of people who would volunteer to be in a research study. So this is something that must be considered, and to some extent we can't know how our research would turn out if we were studying populations that were non-voluntary. It's important that we keep our research data confidential. This can be complicating in child therapy parent interactions. So for example, in the lab, if a child reports to us that they have suicidal thoughts or intentions, we may have to break confidentiality and actually inform their parent of this to keep them safe. But in general, we try to make sure that we're keeping all information confidential, and including information between parents and children. So there are some limits to this, like I just mentioned. Someone's reporting intention to harm themselves or someone else, someone reporting abuse or neglect, or a court order. These are all examples of times when our research data we would have to break confidentiality.